So today we are going to study polar molecules and dipole moment. What is a polar molecule? What is dipole moment? And what is the method to calculate it? So first we study polar molecule. Polar molecules. These are covalent molecules which shows partial ionic character are called polar molecules. These are covalent compounds. So you have to study what is a covalent compound. This hydrogen chloride is a covalent compound because it is formed by sharing of one electron. One electron is shared between hydrogen and chlorine. So hydrogen chloride is a covalent compound. And second is negativity, electronegativity. Electronegativity is the tendency of the atom to attract the bonded pair of electrons towards its side. Here chlorine is more electronegative. So chlorine will attract this bonded pair of electron towards chlorine atom. So as a result what happens? This hydrogen will attain a delta positive charge and chlorine will attain a delta negative charge. So that is shows polarity, or that is a polar molecule. So polar molecules are covalent molecules which shows partial ionic character. So if the two atoms are, example chlorine, both are have the same electronegativity, that is not a polar molecule because there is no shift of electrons. So there will be no delta positive or delta negative charge if they both atoms have the same electronegativities. So one condition is the atom should have different electronegativities and the compound should be a covalent compound. When we are considering some examples, BeCl2. BeCl2. So here, when you consider BeCl2, this is not a polar molecule because the electron will be shifted towards this direction. Similarly, the electron will be here pushed towards this direction. This dipole moment is a vector. So here dipole moment will be 0. This dipole moment mu will be equal to 0. So this will be in this direction and this will be in this direction. So they cancel each other because dipole moment. So what is dipole moment? Dipole moment is the product of the charge and the distance between the positive and negative centers. Product of the charge and the distance between the positive and negative centers. And the unit is dB. dB is the unit of dipole moment. And representation is by mu. So in the case of BeCl2, dipole moment is 0 because it's a linear molecule, they cancel each other. The next molecule BF3, in this case also dipole moment is equal to 0 because here is dipole moment in this direction, and this direction. So here the dipole moment of this will be equal to the sum of these two and in this direction. So they cancel. Similarly, in all these cases, that is mu1 will be equal to mu2 plus mu3. Here if this mu1 and this is mu2 and this is mu3, mu1 will be equal to mu2 plus mu3 and they are in the opposite direction. If this is in this direction, this will be in this direction. So they cancel. So BeF3, dipole moment will be 0. Then another example is carbon dioxide. Here dipole moment will be in this direction. Here in this direction, mu will be equal to 0 because they cancel. So the shape of the molecule is a factor that will determine the dipole moment. Similarly, carbon tetrachloride. This carbon tetrachloride CCl4 dipole moment mu will be equal to 0 because dipole moment in this direction will cancel by this direction. So all this will be cancelled. So dipole moment will be 0 for this. But in the case of water, it is having a bent molecule shape. The shape of the molecule is a bend. In the case of water, H2O, it is having 2 lone pairs. Dipole moment will be in this direction. This is in this direction. So net dipole moment will be in this direction. So dipole moment not equal to 0. Since it is a bent molecule, if it is a linear, they will be cancelled. But since it is a bent molecule, dipole moment is not equal to 0. Sulfur dioxide not equal to 0. So in all the cases, dipole moment will be there. That is not equal to 0. So you consider the dipole moment of, compare the dipole moment of ammonia and NH3 and BF3. NH3 and BF3. In NH3, this is a lone pair for NH3. In BF3, there is a lone pair BF3. The dipole moment of NH3 is higher than that of BF3. Dipole moment of NH3 is higher than BF3. But fluorine, you know that fluorine is the most electronegative element. Even then, this ammonia is having higher dipole moment. That is the dipole moment in this case will be in this direction, and dipole moment to lone pair will be in this direction. All are in the same direction. But here dipole moment due to lone pair is in this direction, but due to bond pair is in this direction. So dipole moment there will be cancellation of some dipole moment because since they are in the opposite direction. So ammonia is having higher dipole moment than BF3, even though fluorine is most electronegative.